Welcome back, everyone. We're going to be diving back into Dr. Alok Aggarwal's insightful book, The Fourth Industrial Revolution and 100 Years of AI.
Glad to be back.
And, last time we were talking about machine endearment and malware injections and all the potential pitfalls with these large language models.
Yeah, some pretty unsettling stuff.
Really makes you think about the potential consequences of AI going wrong. But before we jump back into all that, I think it's important to lay some groundwork here.
Absolutely. Today we will get into one of the core concepts of AI, data.
Yes, today we're cracking open the real power source behind AI, data. We'll explore its crucial role in artificial intelligence, unpack how hidden biases can creep into these systems, and discover why these biases are especially dangerous in certain areas of our lives. And it might seem kind of straightforward at first, right? You might think, well, more data means smarter AI, right? But is it always the case?
Well, as we'll see, it's not quite that simple.
The book jumps right in. It says that more noise-free data usually improves the accuracy of AI algorithms. So more good data equals more accurate AI.
The more good examples an AI has, the better it understands the patterns and relationships, right?
Kind of like us as humans. The more experience we have, the more we learn.
Yeah, exactly. Learning from experience.
But the book digs a little deeper here. It uses two key principles to explain why this happens: the law of large numbers and the central tendency theorem.
And those might sound intimidating, but they're actually pretty straightforward concepts, right?
Yeah, break it down for us.
So imagine you're flipping a coin, right? The more times you flip it, the closer you're going to get to a 50-50 split between heads and tails. That's basically the law of large numbers in action. The more times you repeat a random event, the closer the results will get to the expected probability.
Okay, I see. So it's all about those probabilities evening out over time. Okay, what about that central tendency theorem thing?
That's kind of similar. The central tendency theorem is all about averages. So the larger your data set, the more accurately the average of that data reflects the true average of the whole population.
Okay, so relating that back to AI, feeding it tons of this noise-free data, that's what helps it kind of hone in on that truth that it's trying to learn.
Right? And that's really key, this idea of noise-free data. The author really emphasizes that it's not just about any data, it's about good quality data.
Right? Garbage in, garbage out.
Exactly. And it gets a bit tricky there because then there's this other problem called overfitting, which he also talks about. Have you ever, crammed for a test and memorized a bunch of facts?
Oh yeah, definitely.
But then you forget it all the next day, right? That's kind of like what overfitting is for AI. It's where the model with too many variables but not enough data starts to basically memorize the noise, the random fluctuations in the data, instead of learning the real underlying pattern.
So it's like getting too specific and not seeing the big picture.
Exactly. More data actually helps prevent that too, because the more data you have, the less likely it is that the AI is going to get tricked by those random variations.
So it's like giving it enough information to be able to filter out the noise and find the actual signal. This all makes a lot of sense. But, something Dr. Aggarwal said kind of jumped out at me. He talks about how the accuracy of an AI algorithm may not always improve with more data, especially when you're dealing with problems that are just inherently random or chaotic. And he even uses weather forecasting as an example.
Yeah, that's a great point. And it really highlights that there are limits to these statistical principles, right? So even with tons and tons of data, some problems are just really difficult to predict accurately. You can have all the weather data in the world, but predicting the weather a month out, it's still a pretty tricky business.
Right, those butterflies flapping their wings and all that.
Exactly. Chaos theory.
It kind of makes you think about whether there are inherent limitations to how much we can improve AI just by throwing more data at it. Are there some problems that we might just never be able to solve with this data-driven approach?
Yeah, that's a really interesting question. The book actually suggests that, new approaches, maybe even a scientific revolution, might be needed to overcome these fundamental limitations.
A scientific revolution? Wow, that's a pretty big statement. So we've talked a lot about the quantity of data, but what about the quality of the data? Is all data created equal?
Right? And this is where things get even more interesting, I think, because the book really starts to delve into the issue of bias in data sets. So even if you have a ton of data, and that data is skewed in some way, the AI is going to inherit those biases. It's going to learn from that biased data and then perpetuate those biases in its output.
Oh, absolutely. It really is.
Think of it like you're building a house, but the foundations are wonky.
Oh, I see. So the whole structure becomes unstable.
Exactly.
So more data doesn't automatically mean better AI?
Right? It needs to be the right data. Data that's, free from bias.
Okay, now see, that's where I get a little fuzzy. What exactly do we mean by bias in this context?
So imagine you're teaching someone to cook, but all they ever see are recipes that use salt. They'd be great with salty dishes, sure, but try giving them a recipe for a cake.
Oh, disaster.
Right? That's kind of like what happens with AI. If it's only trained on bias, later it gets thrown off when it encounters something new.
Okay, that analogy makes sense. So bias is basically like prejudice in the data. Got it.
Yeah, you could say that it's when the data favors or disfavors something unfairly, and that leads to all sorts of errors.
But how does this bias even sneak into the data in the first place? Is it like people are deliberately messing with it?
Well, not always. Sometimes it's unintentional. You see, we humans, we have our own biases, right? And those biases can creep into the data without us even realizing it.
So even with the best intentions, we can still end up with biased AI.
Exactly. And that's why it's so tricky.
I bet the book we've been looking at has some pretty crazy examples. Like, what if a facial recognition AI is trained mostly on white faces? What happens when it encounters a different one?
Oh, that's a huge problem. It might not recognize it accurately, and that could lead to some really bad situations.
Wow. Yeah, I hadn't even thought about that. It's like the AI is learning a distorted picture of the world.
It is. And it goes beyond just demographics, too. Think about an AI that's used to evaluate job applicants, but the data it's using comes from a company that mostly promotes men.
I'm seeing the pattern here. The AI could end up like perpetuating that same bias.
Exactly. It highlights how crucial it is to think about where our data is coming from and what kind of biases might be lurking in it.
For sure. So, okay, data collection is super important, clearly. But let's say we've done our due diligence. We've gathered data that's diverse and representative. Are we in the clear then?
Well, it's not quite that simple. You see, even the goal we set for the AI can introduce bias.
Oh, really? How so?
Okay, let's say lenders are using AI to decide who gets a loan, and their goal is to maximize profits.
Makes sense.
Right? So they might charge higher interest rates to people with low credit scores because that's seen as riskier.
Yeah, I can see the logic there.
But here's the thing. The AI, trying to achieve that profit goal, might end up disproportionately selecting poor people for those high-interest loans.
Because they tend to have lower credit scores.
Exactly.
So even a seemingly neutral goal like maximizing profit can end up creating a biased outcome.
It can. It's like the AI is being subtly steered in a certain direction.
That's really thought-provoking. It makes you realize how important it is to really think through the problem we're asking the AI to solve.
Absolutely. And that brings us to another tricky type of bias, implicit bias.
Oh yeah, implicit bias. I've heard that term, but could you remind me what it means in this context?
Implicit bias. So implicit bias is kind of like bias by omission. It's not deliberate discrimination, but rather it's missing information that can skew the results.
Okay, I'm following you.
The book gives this great example about survivorship bias. It shows how easy it is to fall into this trap.
Tell me more about that. I'm intrigued.
So imagine a hospital wants to figure out what helps trauma patients survive. A noble goal, right? But they only look at the patients who actually made it to the ER. They completely ignore the ones who died before getting there.
So they're missing a huge chunk of the data.
Exactly. And that means their findings could be totally misleading.
Yeah, it's like you can't see the whole picture if you're only looking at the survivors. It makes you wonder how often we do this without even realizing it. We make all these assumptions about the data we have, but there might be a whole other side to this story that we're missing.
That's a great point. And it highlights how important it is to be really critical of our data and to acknowledge that there might be blind spots we haven't even considered.
Okay, so we've got intentional bias, unintentional bias, and now implicit bias. It feels like we're uncovering layers upon layers of complexity here.
It is complex, and to make matters worse, bias isn't static.
What do you mean?
It changes.
And how can bias change?
Well, think about how much society changes over time. Laws get updated, and social norms shift. What was considered neutral data yesterday might be biased today.
Wow, so it's like a moving target.
It is, and that makes it even harder to address.
Okay, so it's not just about removing bias from the data we have now. We also have to anticipate how those biases might change in the future.
Exactly.
That's a pretty daunting task.
It is, but it's essential if we want to build AI systems that are truly fair and equitable.
This has been a real eye-opener. We started with this idea that more data is better, but now I'm realizing it's not just about quantity, it's about quality. It's about diversity, and really understanding the potential biases hidden within the data.
You got it. And just to add another layer of complexity, even the purpose for which an AI model is trained can introduce bias.
Wait, really? I don't quite follow.
Okay, let's say you have an AI model designed to detect breast cancer in white women. It might be incredibly accurate for that specific group, but if you tried to use that same AI to detect breast cancer in white men...
Oh, I see what you're saying. It wouldn't work, right?
Right? It's like using a specialized tool for the wrong job. The results could be really misleading.
Makes sense. So it's like every situation has its own unique set of biases to consider.
Yeah, pretty much.
And, we hear so much about the amazing things that AI can do. Revolutionizing healthcare, making hiring more efficient, even self-driving cars.
But all of that hinges on good data.
Exactly. It's like baking a cake. You can have the best recipe, the most talented baker, but if your ingredients are bad, well, you're
not going to have a very good cake.
Oh, not at all. And that's what we've been digging into. What happens when the data that feeds these AI systems is flawed, is biased?
And we're not just talking about, AI making a few mistakes here and there. It's about something much bigger. The potential for AI to actually perpetuate and amplify existing societal biases.
Let me share a really eye-opening example from the 1990s. The University of Pittsburgh Medical Center was working on this AI system to help with pneumonia patients. They wanted to predict which patients could safely be treated at home instead of taking up hospital beds.
That sounds pretty smart, using AI to help manage hospital resources. How did it work out?
Well, here's where it gets interesting. They built this artificial neural network that seemed to be giving really accurate predictions. But when they dug deeper into how the AI was making its decisions, they found something shocking.
What did they discover?
The AI was actually recommending that all asthma patients with pneumonia should be sent home. Can you believe that? And here's the crazy part. Asthma patients are actually among the highest risk group for pneumonia complications.
Wait, how did the AI get it so wrong?
The problem was in the data. You see, doctors were immediately sending asthma patients to intensive care because they knew the risks. So the AI never saw data about what happened when asthma patients weren't given intensive care. It's a perfect example of how biased data can lead AI to make dangerously wrong decisions.
Oh my gosh, that's terrifying. So it's like the AI was saying, asthma, no problem, send them home.
It shows how dangerous it can be to blindly trust AI without understanding the data it's based on.
Absolutely. It highlights how AI can actually make our biases worse if we're not careful. And this problem isn't limited to healthcare. It pops up in all sorts of domains.
Right, like the criminal justice system. For instance, there's a really important case, Loomis v. Wisconsin, where a judge used an AI-powered risk assessment tool.
This tool called Compass was supposed to help determine a defendant's sentence.
Okay, but how does that work exactly?
Well, Compass was trained on a massive amount of historical crime data.
And what was the problem with that?
The problem is that historical crime data often reflects the existing biases within the criminal justice system.
So you're saying the data itself was already skewed?
Exactly. Studies have shown that these types of tools can unfairly flag black defendants as higher risk, even when their criminal histories are comparable to white defendants.
So basically, we're taking human biases and embedding them into algorithms.
It's like baking those biases right into the system.
And these algorithms can be so complex and opaque that it's really hard to untangle how those biases are actually playing out.
Right? It's not always a simple cause and effect. It's these subtle patterns in the data that the AI picks up on.
And we've also seen these kinds of biases play out in the development of self-driving cars.
Absolutely. One of the most tragic examples is the Uber self-driving car fatality that happened back in 2018.
Right, and one of the possible causes was that the AI's perception system failed to correctly identify a pedestrian.
Now, there's a lot of speculation about why that happened, but one possibility is that the AI simply hadn't been exposed to enough diverse examples of pedestrians.
Like different lighting conditions, clothing, all the different ways a pedestrian might appear to the car sensors.
Exactly. And that brings up a really important point about edge cases. Situations that are outside the norm of what an AI has been trained on.
So when it encounters something it's never seen before,
it can make unpredictable and potentially dangerous decisions.
And as AI becomes more prevalent in our lives, we're going to encounter these edge cases more and more.
It's one of the biggest challenges facing the field right now. How to prepare AI for the unexpected.
Okay, so we've talked about healthcare, criminal justice, self-driving cars, but this issue of biased data also crops up in something we probably all interact with on a regular basis. Hiring.
Oh yeah, Remember what happened with Amazon a few years back?
They developed an AI recruiting tool that ended up discriminating against women.
They had to scrap the whole thing. It was a huge embarrassment for them.
But how did that happen?
Well, the AI was trained on a massive data set of resumes submitted to Amazon over a decade.
And I'm guessing most of those resumes were from men.
Exactly. So the AI basically learned that a successful candidate looks like a man.
So it started penalizing resumes that included words like women's or mentioned women's colleges.
It even downgraded graduates from all-female schools.
Wow. So even something as seemingly neutral as an algorithm can perpetuate these deep-seated gender biases.
It really highlights the need for careful scrutiny of the data that's used to train these systems.
And it raises all sorts of ethical questions about fairness, transparency, and accountability.
We're essentially delegating important decisions to machines, but those machines are only as good as the data we feed them.
And what's even more unsettling is that AI is increasingly being used in high-stakes domains like the military and defense score.
That's right. We're talking about autonomous weapons systems and killer robots.
I mean, how far-fetched is that scenario, really?
Well, it's important to be clear that we're not talking about sentient robots with their own agendas, at least not yet.
Okay, so no Terminator situation?
Not yet, but the use of AI in warfare is evolving rapidly, and the potential for things to go wrong is very real.
Can you give us an example?
Sure. A recent UN Security Council report described how autonomous drones were used in Libya with a fire, forget, and find capability, meaning they were programmed to attack targets without any human intervention.
That's chilling. And groups like Human Rights Watch are sounding the alarm about these so-called killer robots.
They're concerned that these weapons could violate international law and lead to the targeting of specific groups based on biased data.
It's a sobering thought. Imagine an AI system trained on data that associates certain ethnic or religious groups with terrorism.
And then that AI is given the power to decide who lives and who dies.
It's a nightmare scenario. But it's one we need to consider as AI becomes more powerful and autonomous.
It underscores the urgency of addressing the issue of biased data in AI development.
Because these aren't just hypothetical problems, they're real-world consequences that are already happening.
And the stakes are only going to get higher as AI becomes more pervasive in our lives.
It's like we're opening up this Pandora's box of incredible potential, but we need to figure out how to manage the risk.
Exactly. We need to be really thoughtful about the data we use and how we use it.
So it's not just about having tons of data, it's about having the right kind of data that's representative, fair, and unbiased.
And that's actually a huge challenge because bias can creep into data in so many ways.
Right? Like the Amazon example where the AI was trained on resumes that were mostly from men.
Exactly. Or think about facial recognition systems that are trained on datasets that are predominantly white.
And then those systems end up being less accurate at recognizing people of color.
It's like we're building these systems with blind spots, and those blind spots can have serious consequences.
So what can we do about it? I mean, how do we ensure that the data we're using to train AI is actually fair and unbiased?
Well, it starts with awareness. We need to be aware of the potential for bias and actively look for it in our data.
So like auditing our data sets.
Exactly. And there are also technical approaches we can use to mitigate bias, like using more diverse training data sets or developing algorithms that are specifically designed to be fair.
And I imagine there's a role for regulation as well.
Absolutely. Governments and regulatory bodies need to step up and establish clear guidelines for the ethical development and use of AI.
Because ultimately, it's about protecting people from harm.
Exactly. We need to make sure that AI is used to benefit society, not to perpetuate existing inequalities.
So to wrap up this deep dive into the dangers of biased data, what's the one key takeaway you want our listeners to remember?
The AI is a powerful tool, but it's only as good as the data it's trained on. If we want to create AI systems that are fair and equitable, we need to start with high-quality, unbiased data.
Well said. So to sum up what we've talked about so far, large amounts of noise-free data are essential for training effective AI systems. However, the quality and representativeness of that data are equally important.
Bias in data can lead to AI systems that are not only inaccurate, but also discriminatory and potentially dangerous.
And we've seen how this can play out in a variety of domains, from healthcare and criminal justice to self-driving cars, recruitment, and even the military.
Yeah, and as these systems become more complex, it's going to be even harder to identify and mitigate those biases. And on that note, I want to thank you for joining us on this deep dive.
In our next episode, we're going to delve into some of the ways we can mitigate bias in data and build more transparent, and accountable AI systems.
We'll also explore some other really interesting aspects of data and AI like ownership, consent, privacy, security.
We'll talk about synthetic data, which is a whole other fascinating topic.
It's a really exciting time to be working in this field. There's so much potential for AI to make a positive impact on the world.
And we're going to be right here covering all the latest developments. So stay tuned, folks. We'll see you next time for another deep dive into the world of AI.
Looking